So I'm sure you must have been fascinated about how artificial neural networks or ANNs, popularly known as, work and how why are everyone behind them, where they are used in transformer architectures, they are used in any type of AI agentic systems that we use today everywhere. So I will try to explain in as much simple way as possible that how were they introduced and how is it very like close to the human society. So basically, first I want to tell you that what is the difference between this. You know that artificial neural networks are a part of deep learning, right? The most cool topic right now. So how is this deep learning, the artificial neural networks, different from the machine learning models that we have studied, like linear regression, logistic regression, random forest, my most favorite. So how are they different? See, I will try to explain with an example instead of just showing you. Imagine you have a picture of a koala or any type of human, even you, and you want a face recognition system built on it. You are first trying with a machine learning model, and the next time you try this with a deep learning model, you give the same picture or the same man, same person to both these models. One is using machine learning, one is using deep learning. Machine learning model will do what? It will look at the whole data set macroscopic. It will divide it into big regions that it can see clearly. Like this can be region one, two, three, four, and try to find relations between these at 1 and 3. Okay, these pertain to eyes and these pertain to shoulders, and the shoulders are stretched, the eyes are also stretched. So try to find this type of information, but in very large regions, and it will look at the data macroscopically all at once. But here, the deep learning model will be quite intricate nature. It will look in data very discretely. It will look at different pixels, individual pixels, or a group of pixels at one time. So it will try to find a relation between them. Okay, if the chest area is squeezed, the nose is also squeezed. Because the nose pixels and the chest pixels it is looking discretely. It even can do multi discretely, but this chest pixels it can also divide into different segments of pixels. So it can go deeper and deeper into the image, but divided into much smaller, just like a cell. So it makes the deep learning models or the artificial neural networks the main framework behind it. They look at it discretely, but the machine learning models did look at it macroscopically. So this is one of the main difference. So how are they different? Like how the artificial neural networks took inspiration from the human nervous system. See, I will also try to explain this with an example. Imagine you have a hot cooking pot, okay, and you try to touch that cooking pot. This is your brain. Okay, you know that the steam is being evaporated from this boiling hot water. And when you touch it, what happens is there are many different neurons. For example, this is a neuron which take input from each of your fingers. These are nerve endings, right? It takes input from each of your fingers. For example, you have 5 fingers, and you have 5 fingers. So it takes all these input from 5 fingers. There is temperature at each of these fingers, one, two, three, four, five. Let it just be features. X1, X2, X3, X4, and X5 will the input from these fingers. It gets to the first neuron. Then it gives this information to another neuron, another neuron. And each neuron has a different task. This neuron might be concerned with if the temperature is high or low. This neuron might be concerned with the temperature is hot or cold. This neuron might be concerned based on surroundings. Is there anyone looking at me or not? So each neuron take must different amount of information and try to process it differently. And at the end, all this information is combined back into the brain, and then brain gives a final output y hat, which is keep the hand or it can be a remove the hand. And from these type of input, it was processed differently at each neuron and finally given information. And based on this information, you either keep the hand on the pot or it will burn and remove the hand or prevent it from being burned. This same architecture is what is used in and here there's not only one neuron, there's a group of neurons working simultaneously using the same type of input but processing it differently. How they process it differently is that the artificial neural network, the ANN, is made of different neurons. And these neurons, I try to imagine nothing but small machinery models. And each neuron has this structure. Take multiple input and give only one output. It takes multiple inputs. These inputs can be of any form, image, audio, video, text, numbers, anything. Let this input be x1, x2, and x3. If so, and all these connections have a particular weight. You must have studied about graphs. So it gives weight to all these features W1, X1, at how important the feature X1 is gonna be for this neuron, W2, X2, and W3, X3. So first part is weighted sum of the input features, summation WIXI, W1 X1 or W2 X2 or W3 X3. And second part is activation function, sigma. This can be any type of function, any type of non-linear activation function. Why non-linear? Because the actual data set in the real world is quite messy. So to capture the intricateness in this type of messy data set, we need a non-linear activation function. It's like a thread or decimal point is non-linear in fashion to capture the complex complex patterns in the data set. And this is what the neuron actually gives. And this output becomes input for the next set of neurons, which again have a different, and each neuron have a different set of weight. That's why each neuron was able to process information differently because each had a different set of weights. And at the end, all this information is combined back because each layer of neural network understand different things. For example, for the picture, one layer might understand face, one can understand one can understand lips, and all this information is collected together at the end and gives permission to access the phone alone. This is how neural network was designed from the same way as a human nervous system works.